Hello everyone. So today we are going to discuss another sorting algorithm, which is bubble sort. So these are the content which I am going to cover in this particular video. First of all, the introduction about bubble sort, the example with which you will be able to understand that how it works. Sometimes it has been asked that because the pseudocode or the loops we can only make after summarizing this entire bubble sort algorithm. Then pseudocode I am going to write for you so that you'll be able to understand or code this particular algorithm. Then every algorithm needs that how much running time you need to execute a particular algorithm. So we'll be calculating that time complexity. And at last, we'll be writing the code in C language. So first of all, let's start with the introduction of bubble sort. So bubble sort is the oldest sorting technique which we are studying, right? It is the oldest one. Actually, the name bubble comes from because as we know that if you have all ever seen that bubble in the water at the water surface, you always found out that particular bubble at the water surface, never inside the water. It happens because the density of a bubble is always less than the density of water. It means it is lighter in weight as compared to the water, if we say in general terms or in a very naive terms, right? So what happens with the bubble sort also, if suppose I am having this array 4 1 2 3, this is 5 elements which has been given to me and I wanted to fix it in an array in a sorted order. Sorted means that we need to arrange these elements in either in ascending or descending order. By default I am arranging them in the ascending order. So if suppose I have to arrange these elements in the ascending order, then what will happen, this is the lightest weight element. So according to bubble sort, it says that whichever is the lightest weight element, it has to be on the first position, and whichever is the heaviest weight element, it has to be on at the last position. So what will happen, this one is the lightest element, so it will come here. Then this 2 is the heavier than 1, but it is lighter in the rest of the array elements present, right? So then 2, then 3, then 4, then 5. Now from here, as you can see that because this is the lightest, it comes at the first position, and it is the heaviest, so it comes at the last position. So this is how bubble sort works in general. Generally, bubble sort algorithm works in passes and steps. Inside every pass, there are certain number of steps, and in these steps, we are going to perform comparisons, right? So I'm going to take an example from here so that it will be easy for you to understand that what is the use of passes and steps and why we are considering this bubble sort to run in passes or steps, right? If suppose I'm having an algorithm, I'm not taking very large array, so I'm going to take this array like this, 2 and 1. This is a sorted algorithm in descending order, but I'm going to sort because default sorting is always ascending. So I'm going to take in the I'm going to make this in the ascending order, right? So as you know, this is the position, this is A0, this is A1, this is A2, and this is A3, just to make you understand, right? And in the case of comparison, in the case of sorting or comparison, always remember that comparison will continue till we have at least 2 elements present in the array, because comparison can only be made with the 2 elements, right? So suppose I am having this concept. These are 4 elements present in this. I have named them A0, A1, A2, A3 because the name of my array is A, right? Now the comparison will be made like, if suppose I am going to make it, this will be my comparison sort. It means this is how I'm going to make the comparison. So in the first pass, this is my array. This is my input array for my first pass. Okay, 0, 1, 2, and 3. So first of all, I'm going to make the comparison between these two. So step 1 will say 4 is greater than 3. Condition is true. So if the condition is true, I'm going to perform swapping 2, 1. For the next one, I'm going to compare it from here, these two positions. Then step 2. What will happen? 4 is greater than 2. Yes, condition is true. So we are going to swap these numbers, 0, 1, 2, and 3. Now at step 3, what will happen? 4 and 1. 4 is greater than 1. Yes, condition is again true. So we are going to perform swapping. 3, 2, 1, and 4. So this is 0, 1, 2, and 3. Now, if you can see that 4, we don't have any other element to be compared. So it means 4 has been fixed to its position. It has reached to that position where it is expected to be, right? So we can fix it from over here. Now we have to go for rest of the array elements. So what I'm going to do, it's pass 2. For pass 2, it means at the end of every pass, we can see that one of the heaviest element present in the array has to be expected to be fixed at its position. So now my array is 3, 2, 1, 4. This 4 is fixed, so I'm not going to take it in this particular sorting, right? So step 1, what will happen with this step 1? This is. So 3 is greater than 2, condition is true. So if it is true, then we are going to perform swapping. 1, 4. It is fixed 0, 1, 2, and 3. 3 and 1. 3 is greater than 1. Yes, true. So what will happen? For step 2, I'm going to put it over here. 2, 1, 3, and 4. This is fixed. This is fixed. This is not to be required to be compared. Right? It is already done. Now we have 2 elements left, but it is done. Now we are not supposed to move ahead. So for pass number 3, we have the input array as 2, 1, 3, and 4. 0, 1, 2, and 3. Now you compare from here. Starting is always from, at every pass you will come back to 0th position and you will start comparing from here. So 2 is greater than 1. Yes, condition is true. So condition, if it is true, then you are performing swapping 2, 3, and 4. 0, 1, 2, 3. Now you see that you cannot compare these two values. It means 2 is fixed. Only 1 is left. You cannot make the comparison. So I'm fixing it over here only. So that's how it is running. So it shows that inside every pass we have steps, and in those steps we are making comparisons, and then in these comparisons, if the comparison condition is true, then we are making swapping, right? So how to summarize this one? So I'm going to summarize this. Now I hope you have understood this example. Now let's see the summary of this one. My number of elements with this example, if I see, it is 4. If I need to ask you how many number of passes are there, then you can see we have 3 passes. So we can write over here. Now with this, you can conclude a general concept. Like in general, we can say that if my number of elements is equal to n, then number of passes equals to n minus 1. This is we have identified, right? From here. Now I wanted to make a summary. I'm representing P for passes, S for steps, and N is for number of elements. So if you see, there are 3 passes, pass 1, pass 2, and pass 3. If you go in pass 1, we have number of steps as 3. If I go for pass 2, then I have number of steps as 2. If I go for pass 3, then I have number of steps as 1. If you add both these terms, you'll get 4. 2 plus 2 is 4. 3 plus 1 is 4. It means mathematically I can write it n equals to P plus S. I hope this is clear to everyone, right? So it shows that because we know n, it will come, and number of passes is directly dependent on n minus 1 number of elements. It means from here I can also calculate n minus P. It means I can calculate number of steps also. I hope this is clear. So from here you can understand that for passes, the loop will go from 0 to n minus 1, and for steps, the loop will go to 0 to n minus P minus 1. Now why I have included this minus 1? Because it is an array and the value will start from 0. First index will be 0. So if you write S equals to n minus 0 minus 1, 0. Suppose minus 1 is not included over here. Then what will happen if my number of elements is 4? 4 minus 0 is 4. It means loop of a step will run for 0, 1, 2, 3. It means 4 times. But as you can see from here, number of steps are 3. It means it is already n minus 1. So that is why I have included in this case minus 1. So that now my n minus 0 minus 1. So it will be 4 minus 1, which again will become 3. So steps will run for 3 times as according to this particular we can see this. Okay. So this is the thing which we need to understand from the bubble sort summary. right? So we have got these two things, that passes loop. Inside the loop of pass, we have got the loop for steps, and inside loops or loop of a step, we have that comparison. And if the comparison is true according to the condition, then we will be performing swapping. So based on this, I'm going to write a pseudocode for this one. Suppose my code is bubble sort. I'm writing a comma n. Okay. So first of all, it is begin. Second, I'm going to input an array of let's say size n. Third, I'm gonna write the loops. So for p is from 0 to n minus 1, do. Inside this one, for s 0 to n minus p minus 1, do. Then in this if condition I'm applying, if a of s is greater than a of s plus 1, then I'm just going to perform this swapping between a of s comma a of s plus 1. Okay, and this is the end of these loops. Print sorted array a of n, and fifth is, so this is how I'm going to make this. Okay, so this is, it'll be done, right? This is the pseudo code. Now it's important for us, we'll be coding this in the C language also, but before that we should need to find out the time complexity. Now if you see from the example also, we can see that every time I'm completing one pass, we are fixing one position and we are only taking care of the rest of the array. It means that we have started from n, then we move to n minus 1, then n minus 2, then n minus 3, up to 1. So it seems like that my recurrence relation for this one has become like this: n minus 1 plus n minus 2 plus n minus 3 plus up to plus 1, because we have stopped this concept when we were left only with one value, because the comparison is not possible for that, right? So now if you see, this is n into n minus 1 by 2, and this is a formula n minus by 2, so t of n equals to order of n square, because this is the largest. So this is the time complexity for the bubble sort. The bubble sort runs for n square in both worst case and best case. We can also optimize this concept, but that we will be discussing in next video. But for this now, for now, we can see that this is the time complexity for bubble sort. So now we have understood the pseudocode, we have understood the example. So now we just fix it. We'll try to implement it in the editor, right? So we should see that how it will be implemented in the C language, right? So now see, void main, you can take anything. Int main also you can consider if you want. A of 10, n, I, p I'm taking as a loop variable for passes, and s for steps, temporary variable, because I'm going to swap. So for third variable, I'm using the swap function. So printf, first of all, I'm writing enter the size of an array which I have wanted to take from user, because maybe user can take out of 10, 5 or 4 values, as we also have taken in our example. %d, comma, %n. Let's input the array elements, enter the array elements. Okay, so for loop, because array will be starting from 0, I is less than n, I plus plus, scanf, this is %d, comma, %a of I. This is all clear for everyone, right? So now I'm starting the sorting concept from here. So I'll be writing, first of all, p for passes, right? P is less than n minus 1, it goes. Now you have understood, I hope, that why it has been n minus 1, because passes are always less than one less than number of elements. Then the loop for steps inside the passes is equals to, you might have got this also, that why we are including this n minus 1, n minus p minus 1, then s plus plus. Now condition I'm writing, if a of s, because I have always considered my first element to be greater than the second element, then only we are performing swapping. So s plus 1, I have done it. So my temporary variable I have taken for swapping. So if it is okay, sorry, I have not included that curly braces. So if it is temp equals to A of S is semicolon. If A of S is equal to A of S plus 1 and A of S plus 1 is equal to 10. This is how we have created this, right? So let's check for this is done, this is done. So now printf sorted array. Okay, so let's see the sorted array. Let's keep it slash and over here so that the output will come in the next line. For I equals to 0, I is less than n, I plus plus, and then we are going to do that printf %d comma a of I. Let's see what is the output from this. So suppose I am writing 4, same values I am writing 4, 3, 2, 1. So this is the output. It is already in the descending order, but I wanted to sort it in the ascending order. So that's why I have taken it like 4, 3, 2, 1. So it has come 1, 2, 3, 4. Right. For ascending or descending order, you can also change like this. The sign only you need to change for descending order. So it will come like that. So this is how the bubble sort works. I hope you have understood the concept of bubble sort. So an optimized bubble sort will discuss in another video. Okay, so thank you.